Mikko Kesslin is up next. And this is the talk that I've been waiting for because Aaron is, we did a hackathon. The reason I know about Aaron, hey, Aaron,
Hi.
so I was just saying the reason I know about you is because we did a hackathon on WebGazer. And you are one of the core team members of WebGazer, and you're here to tell us more about WebGazer, how you guys built this awesome piece of tech, what you guys are going to do with it. And um, I'm gonna leave you to your talk, and I'm really looking forward to this one, so I'll be listening in. So welcome, Aaron, to MintBean.
It's good. It's good to be here, and thank you for having me. Okay, so let me just share my screen. Okay, and there we go. Yep. So yeah, just to preface the whole talk, if you don't know, WebGazer is a piece of software, the JavaScript library that allows you to basically use your webcam and turn it into a rather inexpensive eye tracker. So it's also, just to go back to earlier talk, it's an open source project. So if this talk does interest you and you want to see like how it works and everything, all the code's online, and we are looking for contributors, and there's a lot of very low-hanging fruit. Right now, it's mostly research code, and it reflects that. So there's like, there's definitely lots of room for performance optimizations and just getting it to just build nicely for lots of different platforms and all sorts of, and all of this nice JavaScript frameworks out there. So first and foremost, what is eye tracking? It's pretty simple. The idea is we are determining where a person is looking at on the screen, and you can do that. You need to identify the eyes, and there's lots of very expensive hardware to do this. It's been an active area of research since the 1900s. You can buy all this expensive equipment to do it, as you can see here, and do very invasive studies like that, where you have the patient or the participant just hold still and have like a camera pointed right at their eye and basically show them stuff on the screen. And this is useful for a bunch of tasks, from like cognitive psychology studies, so human-computer interaction, which is the study of like how humans interact with computers, and like various, like how they interact with like GUI elements, how different interaction schemes like mouse and keyboard versus touch screen, and all that kind of area of research. Usability studies, like how usable is your website or app, and also how well does actually work. Marketing, obviously, like selling ads, where do you place ads on the screen, and among other techniques. And what are the limitations right now? So here's a classic modern eye tracker setup. You can see here that you have a standard desktop monitor, and you have this big expensive sensor right here, and you have to go and manually calibrate it. So let's look at the price tag for a simple desktop sensor, excluding the screen, which you probably already have. So if you just go down here, it's $29,000 for the tracker, $14,000 for the tracker for the glasses that the person has to wear, plus, and then with some discounts, and then you need the software to run it. And so just for a very simple system, you're looking at like a $50,000 piece of hardware. So wouldn't it be great if you didn't have to pay for that? So the goals of this project was basically to create eye tracking tools for research on individuals, particularly in a desktop setting. It's to make eye tracking research more accessible, so you don't need all this expensive hardware. Encourage reproducible studies, because now once again, the hardware is less expensive. And you can also do insights on Teams and stuff. Like, imagine if you had Google Docs set up and you could see where your colleagues are looking at, instead of like having to like show their mouse or have them manually scroll. You can just like, hey, like I meant that paragraph over there. And so once again, it's using eye tracking support with collaborations. So the goal of this project is how can we democratize eye tracking? And that's where WebGazer comes in. So a couple things. Once it's free and open source, so it's pretty easy to use. Everyone can have access to the code. It doesn't require special hardware. It can be integrated on more or less any website. It's just a JavaScript file. It's user opt-in because it, once again, uses all the browser environment to both run, and also all the privacy protections. Like you have to, if you want to enable your webcam and such for a website, the browser is very explicit and is very clear consent to basically record your screen. It does not disrupt the experience in any way, and it allows for real-time gaze prediction. And also another thing is it does not actually send any data from the client, so it runs all on the client machine. There's no, so you don't have to worry about, say, sending data back to the server for various privacy reasons, or places or for studies where it might be difficult to do that, like say in like a HIPAA setting, or just trying to get consent from people to basically send off their webcam data to some random place. And so the way this works is basically in 2016, there were some new at the time browser technologies that made this seem easy and practical. So for one, there's the birth WebRTC and the get user media API, which actually this site I'm pretty sure is using. And that was just the first nice JavaScript APIs that could get data from your webcam without having to have a Flash plugin or some other things. And at that point, it started being where all the major browsers supported it, including Safari, which is not here. And so now we have an easy API that's cross-platform you can use to get the webcam. So that's the first step, because obviously if you can't see the user, you can't track their eyes. And the next thing you have to do is you have to detect where the eyes are. And so at the time, we started using JS Object Tracker.js and all these newer techniques that basically run these expensive machine learning modules in JavaScript. And obviously, if you ever use JavaScript compared to C or C++ or Java, it's a very nice language, but it's a very slow language. So nowadays, we actually have modern frameworks like TensorFlow.js, so it lets us do the complex math calculations you need to do to like get all these eye points or all these facial landmarks across people's face and run it at a decent frame rate. And it's able to even use available hardware on the machine, like the GPU, to basically take care of that for you. So you don't even have to rely so heavily on the CPU and therefore slow down the web page as much. And then the next step in the pipeline is obviously once we have the eye regions from those landmarks, we're going to condense that data in. So we're just going to resize those eye patches, correct the grayscale, and just equalize the image, which is just a fancy computer vision word to basically try to make it somewhat lighting agnostic, so that regardless of what brightness it's going to look more similar. And now we have all that. We can do that. We can go and have a model that goes and takes the eye position and the eye appearance and goes and tries to, given say endpoints on the screen, if you record the eye position at all those points, then you can try to fill in some machine learning model to go and predict where the eye is looking and anywhere between those points. And this is a time-consuming and disruptive experience. And so you have to display these things to the user every time they log onto a new website that has this. And so is there some other way we can get this data and also make it so at least initially you don't have to do as many calibration points and make the model more accurate as the user uses it more and more? And so there actually is a queue we can use. And basically the idea here is we take all that input we had before, and the key insight here is basically that there is a strong queue we can use to know where the user is looking, and that is we have the click actions. So when a user clicks on the screen, they tend to be looking at where they're clicking, and therefore each additional click is a new piece of training data. And because this all runs in the browser in pure JavaScript, it's very easy to capture clicks on the screen. And you can even like say, do it as a kind of like overlay where you just add just an additional listener and have it just run on top of any existing web page. And then we have it running into a very simple machine learning module called ridge regression. It's a type of linear regression. That sounds very fancy, but basically all it does is it fits a line to x, y points, but it does that in higher dimensions than that. And that works well because it is a very sample efficient, which means that it doesn't take too many points to start training. And it generalizes well because there is a linear relationship between where you're looking at on the screen and what your eye looks like, and where the eye is looking, because there's a linear relationship between where your head is and where the points on the screen are. And yes, it's cheap. It was also very cheap and easy to implement. At the time, it wasn't very easy to deploy like these more recent like deep neural networks or CNN. If you're familiar with those, it's basically a much fancier machine learning technique. It's all the rage these days. Nowadays, we can actually, the TensorFlow.js uses that, so you can find people's face, but we haven't actually integrated that into the model for going from the eye appearance to points on the screen. And it's also it's fast to infer, and it's also fast to retrain. So if we just want to take all the data we have and completely retrain the model, or like basically recalculate all the parameters of the model, it's really quick to do so. It's within like a couple hundred milliseconds. So even faster than that, it's like more like 50. So here's like, we have a little demo here where we have the user in the top right-hand corner of the screen. They're looking around at the screen, and that red dot represents where it thinks they are looking. And as you can see, people's gaze do tend to focus on where they're clicking. And so it basically gives more and more training data to the model as it goes. And in theory, it should get more and more accurate. In practice, that's not always the case for a variety of reasons. I'll get into that. Later. But you can go and try this, and it's really cool. And you can just basically like you just give it access to your webcam. You click around on the screen a little bit, and now you can have this really cool piece of eye tracking software that's individualized for you and your camera and your lighting conditions without having to know any of those beforehand. Yeah, so in short, basically the idea is we let the user click on the screen. We know where they're looking at based on where they're clicking, and therefore we can go and train a model to predict where they're looking. And so we can go and use these for a bunch of psychology things, like looking at fixations and trying to figure out where they're looking at on the screen. If you have a fixation, basically where someone goes and looks at a particular area for a long piece of time, and the user fixates when they're clicking. So that's how we get the training data. And we can also do it for cursor movement, although it's a much weaker signal. We've also investigated doing it for typing, although that is hard for a variety of reasons, including just figuring out where the cursor is on the screen, where it can be non-trivial, particularly as you stack more and more of these nice React and fancy UI components in CSS. It can be difficult to figure out exactly where the cursor on the screen, and also because not everyone is a touch typist, which means some people are actually going to be looking at the keyboard when they're pressing keys and not at the actual where they're typing on the screen. And that can create a little bit of error that can make model actually be worse if you try and incorporate that. And so we put it all together, and now we can get all this cool data out of it. So we can get things like heat maps and where the user's looking at the screen, and all these cool things. Like you can basically just pull this up on You can add this to a website. You can add this to your personal website. You can see, you can click around a little bit to calibrate it, and then you can see what parts of your website are actually drawing the user's attention. And yep, so one of the benefits of WebGazer, as I said before, it does all the things before. It's also in pure JavaScript. It'll handle and it uses the webcam. It's only a couple of lines of code to add to the website. It acts user permission. It trains in the background more or less, and you can also swap out the machine learning models and mess around with that. So how do you actually include it? You just add the JavaScript file on your website as a source file. You then can optionally add the calibration page earlier, basically have the user click around in certain points. I'd actually recommend doing that because otherwise the user may just like, okay, I'm looking around, why isn't it doing anything? And it won't be doing anything because it doesn't have any training data. Or I guess alternatively, you could be sneaky and collect that training data for a few pages before, like say like reading the instruction for the web page, but then it won't say generalize to the entire width of the screen. And then all you gotta do is it's gonna give you a WebGazer object. There's a set gaze web listener on that object, and then you can simple JavaScript listener, and basically every time it detects a new gaze, it's going to output the position, and you can do whatever you want with that. And basically it's a code overview of it. So there's an index.js, which has all this code to kind of set up these listeners and feed into the models. There's the ridge regression files, which are the actual code to run the models, minus the math utilities and stuff for matrix multiplication. There's the face mesh file, which just gets where your eye is on the screen. And then there's a www folder, which is going to have all the examples on the website. I think actually this would be a good time to stop sharing my screen, actually do a quick demo. So I'm going to do that. So start sharing my screen again and share Chrome. And so you can go to webgazer.cs.brown.edu, and you can go and try it for yourself. You can scroll down here to like ball collision game, and I'm going to calibrate it really quick by clicking around. Take a second to load. Any second now. All right, let this be a lesson in live demos. There we go. So now I just have to go and click around on the screen a little bit, and it's running a little bit more slowly because it is also recording and streaming my screen and the webcam on the other tab. But as you can see, I just click around a little bit. Let me click here and here. And it will run a lot faster on your actual device than probably what it looks like on the screen recording. But I can go look to the right, look to the left, look up, and it's actually going around. I mean, so it's like a little fun demo where we're just bumping balls around, but you can obviously come up with all sorts of really cool applications that use this, and it's not terribly difficult to actually deploy on your app or on your website. So yeah, and let's go and swap back to PowerPoint. So yeah, there's a couple of open issues, like the fact that if you let the user click for a long period of time and they only click in a small region of the screen, that can bias the model. Basically, like if I just predict in that region of the screen, it's always going to be true, which is not the case. So we're working on follow-up now to fix that. And of course, incorporating other data like, say, typing or touch gestures, other clever ways of doing calibration. And yeah, one thing that you guys can help with all is just optimizing the whole thing, like that fancy machine learning part, which just takes your eyes and predicts where the eyes are pointing on the screen, is all implemented in pure JavaScript, which means it's like literally like JavaScript lists that it's going over each element, adding them together. And there's obviously much faster ways to do that, and much faster libraries you can do to actually do those array operations much quicker. So we can get this running on lower end hardware and have it run at a faster rate on phones. You actually can use it on your phone now. It's just it probably isn't, because the screen is a lot smaller, it is not going to be quite as accurate as your computer. And that's definitely another area to look at, is getting this to work well on phones and other mobile devices. And so just to do that, there's a lot of tasks that are open and we're seeking help with. If you guys want to, if this interests you and you guys want to get started contributing to the open source project, there's like no like automatic styling code. There's no JS lint, no nothing. We just got unit test in. There's going to be an NPM package hopefully by the end of the day. If you really eagerly want to try it right now, you can clone it and just do it. You can cloning or download the Git repo and just do npm link to basically get that to point to that folder. It's like doing a global install, but it just points to that folder. And we can also just improve the code in general. Like, it's messy and there's probably like a lot of nicer JavaScript constructs we could be using. We even actually have a web worker implemented, which if you don't know is like getting code to run on a separate thread so that prediction is non-blocking. So it won't slow down the site, but it currently doesn't work because we just overhauled our build system to use a much more modern one instead of just like concatenating all of our scripts together. And also, just one great thing is if you guys just have cool ideas for cool demos or applications, feel free to do them, and you can. And it's really cool. We can add them as under the example section of the website, like that ball demo. Or if you just want to get your feet wet in like simple machine learning or HCI ways to use it, it's really easy to extend. Like if you want to take in more user input and see if that improves the accuracy, or if you want to tweak the model a little bit, it's really modular. So feel free to contribute in that way. And also just getting it on more platforms. Like right now it's a JavaScript file, it's a script file, but wouldn't this be really great as say like about browser plugin, or have it nicely work with all these other frameworks without too much additional code having to wrap the script, like say React or Angle or whatever other acronym they've come up with now. Feels like every day you look away and there's a new JavaScript framework. So just having more examples and making sure our code actually compiles to all those without, say, using only browser-specific APIs, or have like some automatic transpiling stuff to go and sort that out. And it will be hopefully on NPM by the end of the day. It is ready. I just am waiting for the person who actually has the NPM account to upload it. And yeah, mostly hopefully answer the question, can webcam eye tracking be truly useful? We've used it for a couple studies, like looking at where people look at on search results. And we've collected a data set that you can download to of 60 people using it. So if you want like some static benchmarking, you are welcome to use that. And here's like the example we found earlier, where if someone is a touch typist, it's going to be very accurate. If someone's not, it's not going to be. So like if we could detect magically somehow if someone was a touch typist, then we can maybe use that signal, like maybe just have some fancy JavaScript to calculate your typing speed. And yeah, so it's the code can be found here, and I'll just go to once again webgazer.cs.brown.edu to go and check it out, and you can go and see how it works. It's actually, once you remove all the dependency, it's only a couple hundred lines of code, so hopefully not too intimidating. And if you just want to add to your website, it's only a couple lines of code. It's just basically importing the script and using that listener. And I'd just like to thank everyone else who's helped work on WebGazer, everyone listed here. And I started this project when I was an undergrad at Brown, and that way back in 2016. And recently, it's gotten a lot of renewed interest because because people can't even run, even if they have that expensive eye tracking equipment, they can't run those eye tracking studies because everyone's work from home. So they can't like bring people into the office to use that. So it's a really cool thing. It's really useful, particularly right now. And yeah, I'm happy to answer any questions in the time remaining if anyone has that. Or otherwise, once again, thanks for having me. It's been a pleasure.
Hey, Aaron, I had a question. Are you gonna, I don't know if you covered it, or maybe I missed it. Are you gonna support TypeScript?
Yes. So eventually, yeah, that would be a great thing to support. Right now, as I said, the project isn't particularly large, and the main benefit of TypeScript is basically having all those nice, basically making large projects very nice to access. But of course, if anyone wants to go ahead and submit a pull request to go ahead and add that in, we'd be happy to implement. We just haven't gotten around to it. It's been
Cool.
low priority.
You guys should check out Definitely Typed. I'll send you some links. If anybody else wants to contribute to WebGazer, how would they do that? Are you guys accepting contributors?
Yes, yeah. So just go and clone the repo, or which is if you get just a fancy way for downloading it. You can just click fork and download it too. And then once you've done that, you just have to go make your changes, wrap it up in something called a git commit, push it to your fork, and then if you go to your fork on GitHub, there'll be like a magic little thing that says, "Do you want to make a PR out of this commit?" And then you just gotta create that, explain what it's doing, and we can review your code, maybe suggest some changes, and after some back and forth, you can just go accept it, and that change gets landed on the main like source code, and gets packaged in the next version.
Nice. I'm seeing a few comments on the Hopin chat too. Varun Sharma said that he has some startup friends that would definitely implement this. License is free for companies under 1 million valuation. There's a question, what is the pricing model for 1 million plus valuation companies?
Yeah, so yeah. Also to clarify, it's GPL versus, I think it's GPL versus LGPL. And if you don't know the difference, basically what that all that means is any changes you implement, you can large company can just any changes they implement, will basically you're supposed to go and like publish that somewhere, like in your own GitHub repo or as a push. I don't have the exact pricing specifics, but basically, if you really don't want to do that, like if you want to build something proprietary on top of it and redo and like strip it out and like redo everything with like some say like your proprietary machine learning model, then we can then feel free to have a discussion. We actually not I don't think we've actually had anyone come and ask for that yet, because it's pretty easy. If you're going to put on a website, it typically the code will be published anyway. So yeah, but if you want to like say, I don't know, bury it in say like a Node backend or deploy it like on an IoT device or something, and don't want to publish it, that's where the licensing issues come into play. But yeah, there's ways. Yeah, in short, just talk to us if that affects you. But yeah.
Gotcha. So, Vern, I hope that answers your question. I was looking into GPL versus LGPL. When you start understanding how those licenses just trickle down from project to project as the projects fork off each other, it was much more complicated and much more simple than I thought it would be simultaneously.
Yeah.
Aaron, thank you for coming on over here. Have you seen the projects that people put up on WebGazer earlier?
Yeah, yeah. You posted that there. Yeah, there was some really. Or here, you're welcome. You can feel free to share it if you want. Yeah, there was some. Yeah, there was a hackathon about a month ago, or I guess month and a half ago now, that uh, Monarchy ran, and people did a lot of really cool things. And since then, the code has been cleaned up quite a lot, and we've improved performance quite a bit. So, um, yeah,
I'm trying to pull it up because we just changed routing on our website, so we lost a lot of old
uh,
links.
yeah,
But the good news is it's simple to fix. The bad news is we haven't gotten around to it yet. I'm trying
yeah,
to locate it. Um, they were pretty awesome. From what I can see, the NPM stuff is going to make it really easy for people to use this in a hackathon project again. So
yeah. Yeah, and it'll hopefully be up by end of day. And even if it's not, you can do that NPM link trick for local development. Yeah, we should have. Yeah, we're working on it. It's all set now. We just have to go and actually upload it.
hmm, yeah, yeah, NPM publish. Uh,
Yeah.
yeah, it's yeah. But I was going to talk about it, and I decided it's better not to air my opinions about that.
Yeah, exactly.
Yeah, cool, Aaron. Thanks so much.
Yep. Thank you for having me.